Good morning, how are you?
Good, thank you. How are you?
Not too bad.
Good.
Folks are a little slow this morning in coming, but I think what we'll do is crack on with the content because anyone can go back and look at the stream for anything that they missed if they were late. So I want to start today with taking a look at the final assignment for the semester. Aside from, and we'll go through this in a minute, but aside from your weekly exercises, there's a final reflective portfolio piece to put together. I have uploaded the information for the portfolio project. The general assignment requirements are here. We'll go through those in just a minute. There's also the summary of the marking rubric, as well as we've been working with kind of small chunks of a larger data set. The full data file is there so that if you wanted to practice a little more, do a little bit more work so that you're more comfortable and you can take a shot at interpreting, writing your own research questions and hypotheses, because all of that's relevant to the final project. I've uploaded the full data file there. And then, of course, submitting as normally online, you'll do that in this bottom bit, and that is due the 12th of June by midnight. So if you have any questions, once you start getting on with the work on the portfolio, let me know. So let's take a look at the overall assignment landscape for this semester for the module. And one thing to note, I think everyone probably should have seen already the message from the Vice Chancellor. I mentioned it in this week's announcement. But this semester really is an opportunity for anyone to improve their overall course mark. There is really no way that this semester can penalize students, because what the message coming from the university has said is that for your annual progression, for everything else, the marks for the semester are only going to be counted. Let me rewind. Only 50% of marks for the year will be counted. So it's your top 50% of modules. So that has a couple of implications. First, and most importantly, is that everyone needs to complete and pass their modules this semester. So you need to make sure that you have something handed in for the required components for each module. That said, really, the way that the accommodation for the coronavirus is working out is that the work you do this semester will only improve your standing. So it's both hopefully a weight off, but also an encouragement to do really well on the projects. And from the looks of it, in the two modules that you guys have with me, the digital and the research methods, you guys have done well this semester. So I would encourage you to kind of keep that up as we push to the end. And you have a good chunk of time that even if you're working crazy, if you have disruption, there's still a good amount of time left for everyone to get things done. So this module, the weekly exercises that we've been doing, those are worth the lion's share of your module mark, because it's the core heart of demonstrating your competence in running the tests and interpreting the tests. So as we go through them, the final exercises are really about trying to make sure that you have the basic skills. But the portfolio project itself, and what's coming up that's due on the 12th of June, is really about showing and reflecting on how you've done and your confidence in using quantitative data, analyzing it, using that to answer research questions or test hypotheses. So part of this is, how do you make the argument for yourself as a researcher? So I'm not really interested in some kind of delightful fiction about how good you might be or how amazing you think data analysis is. This is meant to be a nice reflective piece that is honest, and it lays out how you've done in support of some broad goals. So the broad goals for the module are about self-directed learning. So you're looking for the connections, and this is actually part of good research methodology, no matter whether you're doing it qualitatively or quantitatively, is that it is an exercise in critical thinking, of thinking about how to situate what you've learned in a bigger context. So it's moving beyond just, that we have this very siloed experience of this module and how does, can you get through the assessments in the module, but what could this mean in terms of professional development, even in terms of being a critical consumer of information? I mean, even right now with COVID, we are seeing and experiencing a lot of different data being thrown at us. Can we critically look at the data and the information and begin to make good judgments? Face coverings are this week a big deal, and the question is, should we wear them? According to data coming in from a lot of other countries, there's a very good case to be made that they reduce transmission when everyone wears them. That's why, for example, in Germany, there's a 5,000 euros fine if you're not wearing a face covering of some kind when you're out in public. Greece, apparently coming on Monday, is instituting a fine and the mandate for it as well. So these are reflections based on the best information. So it's more than just can you do and can you complete a project for some module. It's about how do you use numbers to reason. So these are really encapsulated in these broad goals. So again, take note that this date has been updated. Let's go to June 2020. When you're submitting your portfolio, submit it as a single document, and it needs to be either a Word document, .doc or .docx, or a PDF. So it needs to be able to be opened in My Beckett, and those are the only two formats in terms of the word processor formats that it can use. Big picture, the portfolio is about 2,000 words. This excludes any appendices, references, tables, and figures. It's just the core text of the document itself. So I'm looking for you, as I mentioned, to reflect about your own abilities, and it's not about making yourself look good or worrying about whether I think you're a good researcher or not. This is really about how you can show evidence for what you can and cannot do, or what you're comfortable doing. So it's about how do you connect evidence with assertion. So good arguments, I expect to have these qualities. First, it's a clear claim or assertion connecting your knowledge or experience with the particular learning goals that are set out. Second, an explanation of how your knowledge demonstrates the requisite level of competence for the learning goal. And third, the support for the assertion that you're making. Now, if your conclusion is that you have not met the learning goal, that's not going to be counted against you. So I don't care what your reflection is. What I care about is that you can make an accurate assessment of yourself, explain it, and provide documentation and support for it. So make sure that you're working through that with each of the big learning goals, and you'll do fine on the assignment. So let's take a look at the 5 learning goals associated with this portfolio. And again, it's meant to be brief. So with 5 learning goals, you're talking about a page, 400 words of text for each one. So you need to be succinct and you need to be clear. And of course, that, as I said, excludes the references, appendices, tables, and figures. So when you're putting your portfolio together, I'm looking for for demonstrated competence in analytical methods, and what each of those mean we'll go through. Demonstrated ability to execute quantitative tests, to interpret and report the data correctly, to produce clear research reports, and to provide conclusions regarding what we know, and professional readiness. So you'll be evaluating the degree to which you've met the goal and providing proof of that. So, like I said, your grade is largely determined based on the quality of your own analysis and the ability to document your progress and authenticity of your assessment. So you've already been graded at that point on the work that you've done in the semester. I'm not looking to regrade that. What I'm looking is for the ability to reflect and even supplement the work. So let's say you had an assessment that you didn't do particularly well on, and you want to show competence with it. That's why I've posted the data, so you can show that you have actually improved that, or you've tried it in different ways. So that's why you have the option to run additional tests to do more work on that. So let's take a look at the specific requirements. So have a good introduction that brings everything together, about a paragraph at most. But it should have these 4 qualities: has a strong opening, a strong central argument that binds all of it together, provides a rationale, and previews the main points in the paper. This is basically what every introduction should do, so these are what I'm looking for in a good quality introduction. So when we get into the first section, Learning Goal 1, Competence in Analytical Methods, what I'm really looking for is a demonstration of competence with basic statistical concepts and quantitative decision making. So offer a quick introduction that summarizes the big picture, a few sentences, at most a paragraph. But then, for each of the requirements, here's the type of information that you can provide in it. So I've probably gone to a lot more explanation than you may even spend with your summaries. But what I wanted to do was to give you an overall sense of the type of information you can include. There are a lot of ways to write these assessments, but I'm looking for consistent, well-structured arguments. So there's an idea of the types of evidence that you might include, a summary of evaluation, overall assess the strengths and weaknesses, and something really that I'm looking for with each of these learning goals is the question, is this something that you can put on your CV? For me, this is part of what you should be doing. So if you're looking about it, thinking about this in terms of professional development, how can you use research methods on your CV? Now, one of the things that we've talked about is the increase in interest in people who can show both digital, critical thinking, or all 3, and research methodology in terms of what the profession is lacking and what might be asked for that can set you apart. This is one of those elements that can set you apart as a young professional. So with the quantitative decision making, and keep in mind, this isn't really saying, oh, you need to be a data analyst in your career, but it's taking a look at whether you can use data to make good strategy, reasoned inferences, and so this element of quantitative decision making, that's what I want to see. So in this section, this isn't a huge research piece, but I do want you to make sure that when you are discussing it, for example, that you clearly define what you think quantitative decision making is using 2 credible sources. Now, those may be academic or peer-reviewed sources, but they could also be industry sources. So there are a number of different agencies who are doing a lot of research when it comes to quantitative research and quantitative decision making. They can be credible sources when you're looking at this. So a brief reflection of how this comes together and then identifying and evaluating your competence in it by identifying the strengths and weaknesses. So it's about being concise and precise in your analysis, but then pointing to the evidence of it. So showing tables, showing summaries, including working appendices, whatever you think might be appropriate in order to demonstrate that you have whatever degree that you have of this. And then briefly, as you conclude that, reflect on how quantitative decision-making may play a role in your professional life. So this is about connecting it to the field. The second learning goal is demonstrating the ability to execute professional research. So think of each of these learning goals as stacking one on top of the other. So where you have to demonstrate in the first one that you knew what you were talking about, in the second one you want to demonstrate your ability to perform different kinds of statistical tests. So this is where a lot of the evidence from your exercises comes in, and I'm looking for you to make an overall assessment about your competence in executing the basic statistics that we've covered. So use this kind of a rubric from expert to unable in order to classify your assessment, but then make sure that you have the evidence to support that. So be sure that you can correctly identify that it's running the tests, not necessarily how good your interpretation is. That's a second and a different learning goal. But can you go into SPSS and can you run descriptive statistics, t-tests or correlations? We took out the chi-square, so you can ignore that. Can you run an ANOVA with a post hoc comparison? Can you run a regression? So you can use for this any of the relevant exercises, or if you wanted to include additional ones, you certainly can. Again, that's why the data is there. So you could also use analyses from other modules or projects. If you're doing something for your GlobeCom project that would be appropriate, you could certainly use that. Or if you did something for your digital media that entailed some kind of a quick survey, you could use that. Any of these would be appropriate. The third goal is demonstrating your ability to interpret and report. Again, we're layering on. So you've shown that you understand what the quantitative methods are, that you can run a test. Now, can you make actionable recommendations and interpret the data in a way that is concrete and applied? So this is the real point of doing research, is can you make strategic recommendations? So, and across multiple tests. So what can you say if you find a significant correlation or a significant ANOVA? What can you offer about them that is accurate and fair to the information that you've found? And again, we use the same kind of rubric as far as the expert to unable. And again, make sure that you have evidence supporting that. And this is, can you explain in plain language what the results mean? Can you pick out what the results mean? And across the same tests that you had on demonstrating the competence with it. So, a lot of the questions on your, especially the last few exercises, focus on correct interpretation. That is one of the examples that you can make. You can also do your own analyses, and again, any other projects that would be appropriate to that. The fourth, can you produce a professional quality report? Now, part of this is being able to really pull it together to go from the start to the finish. So the three elements that I'm asking you to reflect on here is that you can correctly report the data. In each of the weeks we've gone through how to report. Can you test hypotheses and draw conclusions from those? And then third, can you make a strong recommendation based on the results? So in part of this, you want to think about how you summarize your ability to do that, and then go through each of them in turn. And again, these don't need to be lengthy. And you can use the same kinds of evidence that I've been talking about for each of them. So you make sure that you have these elements, that you can reflect accurately on them, that you can talk about exercises, work that you produce on your own, and then ultimately, and the reason to do all of this, is the ability to make strategic recommendations for organizations. So what kind of recommendations can you offer? The stronger your claim for the ability, or for this ability, the more evidence that you need to offer. So that's something to keep in mind, that you can show in tables, in recommendations. You can use the exercises, anything that really demonstrates how you can move from simply the reporting of the data to the specific recommendations. You can be creative. The idea isn't that you're doing a ton of external research. Aside from a few sources in reflecting that I asked for earlier, most of this is all about the data analysis and what you can show. Think about it in terms of what can you put together for a portfolio. The relative strength of the work that you can do, how would you show this to a prospective employer? If you want to put this as a skill set in a job application, on your portfolio, whatever the case may be, what can you actually show to an employer? And then finally, provide conclusions regarding an organization's professional readiness. So we do this, not surprisingly, in crisis a lot of times. Is once we work with an organization, hopefully ahead of a crisis, we identify what their potential weaknesses are and make recommendations about how the organization should change in order to mitigate their risks. A lot of this is based on quantitative data. So thinking about it in terms of knowledge development and looking at your reflection, how your knowledge of research has changed over the semester with regards to these areas, using it in a PR corporate communication context, your knowledge of the methods themselves, conducting and analyzing research, summarizing and reporting it, and then thinking about what kinds of tangible skills or certifications you could put on your CV after completing the module. And then finally, the professional readiness. And there's two ways really, I think, to test or to assess your professional readiness in terms of quantitative analysis. First is to show to what degree could you conduct data analysis as part of your job. Would this be something that you would want to include as part of your professional profile? And most of you probably won't be in this category. However, most of you should be thinking in terms of the second category, your professional readiness as a strategist, because this is something that all PR and corporate communications folks need to be able to demonstrate, is how can you help build evidence-based strategy for organizations. This is something that you can really demonstrate and communicate knowledge and experience about. So it's not necessarily whether you can write the best questionnaire, that you can do the most complex analysis, but what can you do with the information once you have it? Now, as you're going through each of these, I want you to think about your overall grade, what you would give yourself. Please keep in mind that this is not how I'm going to grade your performance, but I want you to grade your own work. So I want you to identify the letter grade that represents your overall work across the semester. So this is based on the other learning goals, how you've put it together. What would you give yourself based on this rubric? And how would you defend that? That's what I'm looking for you to give yourself about it. Again, this is not about a judgment about you or your performance in the module. This is about an assessment that you would make of yourself and your ability to execute data analysis and draw conclusions from it. So I'm looking for a good assessment based on the module objectives as well as the learning goals for this project. How do you reflect on that? So then some of the niceties, of course, make sure you have your references, your appendices, and then your tables and figures as you would want to include them. You can take a look at the rubric. It's not that different from any of the other rubrics. When you start working on your project, if you have any questions, let me know. Again, this is not a desk research where you're looking up a ton of different sources. I think for the whole thing, I require at least 2 quality, credible sources. Most of this you should be drawing from the work you can demonstrate. So your research is actually the quantitative analysis for the most part that we've done. Just your ability to connect it to something a little bit bigger. So that is the big picture with your project. Make sure as you go through that, as you're working through it, just work through it one learning goal at a time, and keep in mind that you're looking for no more than about a page. If you assume single space and like 12-point Times New Roman or Calibri font, that's right around 400 to 500 characters. And before you ask any questions about it, I'm not that bothered if you go a little bit over or a little bit under. You know, if you're grossly over, if you're more than about 2,500 words over, then you're probably not being as succinct as you should be. So just make sure that you're having clear, simple, straightforward assessments, and you guys will be fine. Let me know, like I said, if you have any questions or if you have any problems. So let's shift from that then into the actual tests. So let's take a look at the 2 tests that we're going to be running this week, correlations and regression. And the reason that we're pairing these 2 together is, quite frankly, that they are just paired together most of the time. So if we think about, and we hear this word correlation all the time, but what really is it that we're talking about when we're talking about correlations? Very simply, they describe the relationship between 2 variables. So as one variable is observed, what happens to another? You know, let's take a really simple connection. The more clouds there are in the sky, the more likely we are to see rain. That is basically a correlation. So that would be a positive correlation, and we'll get into all of that in just a minute. But that's the relationship. If you see 2 things occurring, then what can we say about it? So face masks. If everyone's wearing face masks, we see a drop in the transmission of COVID-19. That's a relationship that has been observed. So the 2 types of correlations that we have is a positive correlation. So that's our clouds and possibility for rain. So as there is an increase in one variable, we're also likely to see an increase in the other variable. So in this example, this is looking at the relationship between income and years of education. So as years of education increases, that's the vertical axis, then we are likely to see an increase in the amount of income that people have. And if this is the data, you can see the little, I don't know, blue house. They kind of look like a house, but the blue dots there are people's reporting of their incomes and their level of education. So even if you kind of look at the scatter as those dots go up, you can see that there is generally a positive relationship. More education, typically speaking, leads to more income. That's what we mean by a positive correlation. Note also that that works in reverse. The less education people have, the less income that they're most likely to have. So a positive correlation just means that the variables move in the same direction together. They either increase together or they decrease together. The second type of correlation then is a negative correlation. So in this case, as one variable increases, the other variable decreases. So in this case, in the comparison between someone's grade point average, it's a bit of an American reference. It's like the first, second, third degree honors, just numerically done. And the hours of week that people watch TV, so the more hours of TV that people watch, the lower their GPA is. You can flip that also around to say the higher people's GPA is, the less TV that they watch. And again, if you look at the blue dots, you can see here that if people are at say a 2.0 level of their GPA, then they're watching a lot more television than the people are between 3.5 and 4.0, which is the higher GPAs in the US. So that's what it's asking about in this relationship is that as one variable goes up, the other has to go down. You can word it any way that you want. That doesn't matter a whole lot. So whether you word it as one is going up, the other is going down, or as one is low, the other is high, it means the same thing. So sometimes people get confused in terms of the direction. So sometimes people say, well, can it be a negative correlation if we're looking at the drop in two things? Of course. The fewer clouds in the sky, the less chance there is for rain. That's a drop in the correlation, but it's still a positive correlation. GPA, the more TV we watch, the worse we do at school. No matter how you word that, that's going to be the same kind of relationship. So with correlations, when you're looking at these in terms of printouts, the range of correlation goes from a plus 1.00 to a minus 1.00. So if you're dead in the middle, 0, it means there is no relationship, no statistically significant relationship. So the closer that you go to a plus or a minus 1, the stronger the relationship is. So the plus 1 is just a positive correlation. The minus 1 is just a negative correlation. So we go back to the big question, which is, what's the purpose? So we try to identify what relationship exists. This is really an important first step in most scientific and social scientific endeavors, is because we're going from observing something in nature to saying, does it meaningfully exist? So we can observe that there's clouds in the sky, or that it seems like students who watch a lot of television don't do as well in their classes, but that's not really a conclusion that we can draw in terms of making action. We would never want to adjust policy, would never want to make predictions based on mere observation. Mere observation is a starting point. This lets us move to a much more fine explanation. But then, once we have that relationship, we want to know if it's causal. So, does television actually cause students' GPAs to drop, or is it merely an indication that people who have poor GPAs just don't spend that much time studying? So this is the next challenge that you have to overcome, is that there's actually a fallacy. About the fallacy of correlation means that just because two things are related doesn't necessarily mean that one causes another. So this is why we also consider regression. Regression says, okay, so there's a relationship between two variables. Is that causal or not? So think about the purpose of correlation to identify if the variables are significantly related. There's no element of causation, and there's no independent variable nor dependent variable. One does not cause the other. It just means that they happen in a time because we have no evidence of one causing another. That's why you can't have an independent or a dependent variable. So the purpose of regression then is to investigate the causal relationship between the variables. Now this is only looking at positive and negative relationships. As one goes up, what happens to the other one? Now, in both cases, they're scale variables. So they need to have a range of numbers, and that range of numbers, the numbers need to mean something. There's a whole lot of complexity that would be worth getting into in, say, a later analysis of statistics if you're wanting to, with dummy coding variables and this kind of thing. But generally speaking, think about age. Age is a good example of a scale variable. As people get older, what can we expect out of their attitudes and their behaviors? So the dependent variable then also has to be scale. So this is the key difference between the ANOVA and the regression, is that in the ANOVA, the independent variable is categorical and the dependent variable is scale. In a regression, both are scale variables. So that is the critical difference between the regression and the ANOVA, based in the practicalities of what kind of variables you can use as independent variables. So when we're doing regression, we always start with correlation. So we check the correlation, and this is what our correlation looks like. R always refers to the correlation. Again, it's like the F on the ANOVA or the T in the t-test. It is just the way it is. So in this case, R equals negative 0.24. So we know it's a negative relationship, and we see our p-value is less than 0.05. So we know that if this were our correlation, that it is a significant negative correlation. So let's say we're talking about our school, our GPAs, and our television viewing. If this were the case, that there would be a significant negative relationship between watching television and performance at school. But this might be linear. We just don't know whether it's causal or predictive yet. So the regression identifies the causal connection. So this is quite a practical question that we can ask. So if we were thinking about BP and the BP oil spill of 2010, stakeholder evaluations of BP's commitment to clean up the Gulf of Mexico significantly influences their motivation to advocate against BP. This is a statement that we can test. So if we had that negative correlation, if we go back one, if our correlation for this were negative 0.24 with a p-value less than 0.05, we would know that there was a relationship, that the worse stakeholders' attitudes about BP's commitment, the less they judge BP as being willing, they are highly motivated to advocate against BP. So less commitment leads to greater motivation to advocate. Here is what and how we would report for this particular regression if we ran that. So let's break this down into each of the parts. You'll notice the T is familiar. T-tests, when you're doing a regression, it's the T-test again. Because it's based on the same principle and the same underlying mathematics as the T-test that we covered a few weeks ago, we use the T as the starting point for a simple regression. So a simple regression is when you look at one independent variable's influence on a dependent variable. Here, our independent variable are stakeholder evaluations of BP's commitment to cleanup, and the dependent variable is their motivation to advocate against BP. How do I know that? I know that from the statement itself. When you're looking at a hypothesis, you're looking for the variable that is the causal variable as being the independent variable. So if you see something that this variable significantly influences another variable, it's a variable that is doing the action that is the independent variable. The variable getting acted upon is the dependent variable. So the t-test, when you see it in this kind of an equation, signifies the regression test. The 781 is our degrees of freedom. That represents the number in our sample. The negative 6.89 is the value of the t-test itself. For the most part, the most important bit is that you're looking at whether it's a positive or negative. Because we had a negative correlation of the negative 0.24, we would also expect the regression equation to have a negative relationship, because that's the relationship between the variables. There is a negative relationship between commitment and motivation to advocate. The p-value, as always, needs to be 0.05 or lower. It's 0.00. And then our adjusted R-squared. For regression, this is almost after the significance to tell us whether we have something that is meaningful. The adjusted R-squared is the most important statistic that you can look for. This tells you how much the variance that you've actually accounted for. Think of this like a big pie. What we're trying to account for is as much of the pie as possible. So when we're thinking about how to predict whether or not people are going to advocate against a company when they are in crisis, we want to know and account for as much of this pie as possible. So we want to know all the variables. Who is more likely? What attitudes are likely to be relevant? Because that tells us who we need to target, the types of messages that they are going to need to hear in order, and what the content of those messages might be in order to mitigate the negative outcome. For, in this case, advocating against, either through boycotts, social media, whatever the case may be. Now, with the adjusted R-squared, you can convert that to a percentage. To do that, you move the decimal places 2 points to the right. So the 0.06 comes out to 6%. So that means that we can account for 6% of the likelihood or the motivation for stakeholders to advocate against BP, just based on understanding if they think BP is committed to cleanup. So it's meaningful. If you think about the kinds of campaigns and the kind of impact of campaigns, in most commercial campaigns, a 3 to 5% impact on people's attitudes or behavior is considered a commercial success. This single variable on its own accounts for 6% of people's attitudes. So you could reduce, if you had 100 people, based on this prediction, if you had 100 people, you could reduce 6 of them, their likelihood to boycott BP, just based on communicating commitment to clean up after themselves. If you start to think about it in terms of magnitude, profitability, all of that, even though the 6% doesn't seem like a big deal, it actually is when you start considering across larger populations. When we're talking about health issues, this becomes even more. Imagine if you could reduce, even by 6%, the likelihood of people getting COVID. That means a lot in terms of difficulties, deaths, things like that. So this is why even small gains are meaningful once you start to amplify it across the population. So that's how you would interpret the adjusted R-squared. And it gives you a sense of the impact of what you're talking about. So when we're talking about interpreting the findings, we can very clearly see that BP's commitment to cleanup makes stakeholders less likely to advocate against BP. But of course, there's never only one cause for people's decisions. One of the things that regression tests make really easy is adding multiple non-correlated variables to each other to account for more variance. So think about all the different things that can change people's attitudes about whether they support or even like an organization. It might be their gender. It might be their age. It might be whether they're a previous customer or not. So there's loads of different things that can go into decisions. What regression allows you to do is to actually add those in one at a time and see how much impact each of them makes. So if we ask a broad question, what else could influence people's decisions to advocate against BP? Let's imagine that we added in their age, their gender, which again is a tricky one, but if you code it, 1 is male and 2 is female, and take out anyone who answers anything else, you can get a mean that is a range. So in this case, it's not that the 1 or the 2 is meaningful, it's just that the average might tell you which direction it trends. We might also add in their political attitudes. Now, what you'll see when you, instead of saying political attitudes, you'll see them labeled more specifically, if depending on the scale. Is it a conservatism scale? So the high end of the scale means you're more conservative. It's not a good or a bad judgment. It's just telling someone who reads that a higher score means that people are more conservative. A lower score means that people are more liberal. And then also their perceived knowledge of the company. So if we add in those 4 things, in addition to the motivation to clean up, people's attitudes about the commitment to clean up, what do we get? Well, all of a sudden we get a statistic that looks a little bit different. We're down to an F, and this is somehow, if we remember, the F is the ANOVA. Well, what regression does is it will test for each of these individual variables, but then it asks an overall question. Do all 5 of these, or all 4 of these, including BP's commitment to cleanup, together, is that significant? So when you have what's called a multiple regression, you'll see the F statistic reported. So if you have seen someone run a regression and you see just the T, they're looking at a single independent variable. If you see them report an F, they're reporting for a multiple regression. That's the difference between them. So how do we interpret this? That the F is different? Well, it ends up that you're taking into account all of the variables together. And so when you're interpreting it, this is actually how you would see it reported. You get the overall test here with the F at 5, which just tells you the number of variables considered in the test, the 775, which are the number of participants in the study, the 29.69, which is the value of the test, and then of course the significance, the P is less than 0.05, or you report the number. On your printouts, and we'll take a look at these during the demonstration, you also get the individual scores for each one of these. So what you can look at is the comparative impact for each of the variables themselves. So when we take into account all of these together, we start to get a very different kind of a picture. Age certainly does matter. Gender matters in this case because it's a positive number, and I always happen to code male as 1, female as 2. That just means that women are more likely to be motivated to protest against. Conservatism, because it's positive, we know that people who are more conservative were more likely to protest or advocate against. Perceived knowledge of BP, that again, because it's a positive number, that the more knowledge that you think you have of the company, the more likely you were to protest. The age, I didn't look at that one individually. It's a negative. So the younger you are, the more likely you are to protest. And then adding this into commitment to clean up, that the more likely you think they are to clean up, the less likely you are to protest. So that's the negative relationship. When we put it all together, all of a sudden we have a really nice chunk of the pie that we can account for. And even if we look at just BP's commitment to cleanup, taking into consideration all of these others substantially increases its overall value. So you would actually be able to add all of these together, the 0.01, the 0.02, the 0.08, so that's 0.11, add in the 0.13 is 0.24, add in the 0.16 is 0.30. So we are taking into account and accounting for, with this single test, 30% of people's attitudes to advocate against PP. So we can predict pretty well then who is more and less likely. What this would mean is that if we wanted to reduce protests, we would need to communicate with younger, especially female audiences, who were more conservative. We would also try to change their perceived knowledge, that they have come to a judgment about BP and its commitment to cleanup, and we would want to change those two things together. So this tells us not only who should be targeted, but that it suggests the strategy that we should target. So this is kind of the intelligence that we can communicate and that we can use in order to build strategy for. So this gives kind of in a nutshell why we do both correlation and regression, and also how it is that we can use it strategically. So let's come back to our week 5 exercise for a minute. So our objectives for this week are to learn how to run and interpret the correlation and regression, and then be able to apply those tests to specific hypotheses and answer particular questions. The details are there. So when we are taking a look at your homework assignment for the week, or the exercise for the week, you're going to be testing 2 hypotheses and answering 1 research question. So that's what you'll be doing for yourself. In the demonstration, I'll go back in a second to the hypotheses that we're going to test. But so this is what you guys will be doing this week, and answering the questions based on those. So you'll be looking at price-reduced shopping style, and we'll look at that in the data in just a minute, and also consumer beliefs and values. So for the demonstration, however, we are going to look at 2 different hypotheses. We're going to look at consumers' beliefs and values, and testing that beliefs and values will significantly influence consumer attitudes about the suitability of yellow sticker food, and also that consumers' beliefs and values will significantly predict the amount of money they actually spend on price-reduced food that had a short expiration date. So stuff that instead of going out of date in a week might have been going on out of date in 2 days, and so they knock the price down so that they can get it off the shelf instead of having food waste. So that's going to be the general, those will be the tests that we run for the demonstration. So let's have a look at our data. This is what your data set will look like. And so these are the variables that we have for this week. So beliefs and values, you guys will be using the beliefs and values to answer one of your research questions, or to answer the research question, but mostly you'll be looking at the type of food shopper. What you notice here are that there are 4 variables that look at different types of beliefs and values that people might have, and 4 types of food shoppers. So we looked last week at the types of food shoppers and what factors influence them. Now we're saying, as a food shopper, what impact does that actually have on people's attitudes about their actual spending, They're evaluations of yellow sticker food and their food waste. So, in the land of independent and dependent variables, beliefs and values and the type of food shopper are going to be our independent variables. Our dependent variables are going to be the yellow sticker food evaluations, the money spent, and then food waste. Why? Because we're interested in and we believe that the beliefs, values, and the food shopping styles are going to affect these other variables. So let's take a look at our first hypothesis, that consumers' beliefs and values will significantly influence their attitudes about the suitability of yellow sticker food. First thing that we have to do is run the correlation. So you go analyze, correlate, and we want the bivariate correlation. Now, it really doesn't matter what order you put these in. My suggestion is to put in the dependent variable first, and I'll show you why. So our dependent variable here are their attitudes about the suitability of yellow sticker food. So we pop that across. Then we take a look and we choose all the beliefs and values. Hold down the control button if you're using a PC to get them all at once. And we don't need to change anything else when we're running the correlation. You put those in. The correct correlation in Pearson, we want two-tailed, and we want it to flag significant correlations. All that's done for us. We do not need to mess with any of these over here for the correlation, so we press OK. Now, the reason I suggest putting in the dependent variable first is it means that we only need to look at this first column. It makes this whole printout a lot easier to read. Instead of having to look across at the rows, we just look down the line at the food sticker evaluations. Now notice how there is a perfect correlation, a 1, between yellow sticker food evaluation and yellow sticker food evaluation, of course, because that's comparing it against itself. You see that all the way down this diagonal column here. So when you're looking at a correlation table, you can think of folding it in half diagonally. So what is up here above the diagonal row of 1s is exactly the same as what is down here below the diagonal row of 1s. So already, depending on the way that you would prefer to look at this, if you're reporting the full correlation table, you can ignore the top half or the bottom half. There is no right or wrong in that in terms of creating tables. It's just a preference. But when we're using the correlation to help us figure out what we should run for the regression, we only look here. Now, this tells us, so the Pearson correlation, if we go down to this first column, the yellow sticker food evaluation suitability and the social responsibility. Right, so this first line, Pearson correlation at a 0.16. There are two ways that we can know that this is significant. One is to look for the nice little asterisks. So if you see the asterisks, take a look down here at what they mean. So one asterisk means that it's significant at just the 0.05 at least. Two asterisks means that it's significant at the 0.01. So that gives you an easy thing to look for. But we can also look at the significance, which is the same thing we've been looking at all along, and we see it's 0.000. Of course, there'll be a number over there. That means it's really significant, right? And then we also get the N. 792 people responded to both of those questions in order to draw that correlation. So as we look down our column, we see that all 4 of the values that we tested are significantly, and notice all positively, correlated to yellow sticker evaluations. So this means that the more people identify with social responsibility values, environmentally shopping behaviors, domination, and anti-environmental values, the more likely they are to evaluate yellow sticker food as suitable. What's interesting is that these are two very different types of demographics. Typically, the folks who really like social responsibility and environmentally friendly shopping behaviors are going to be really different people than the people who identify with domination type values and anti-environmental values. So the fact that all of these very diverse groups or both of these very diverse types of groups all identify with the suitability of yellow sticker foods probably tells us that yellow sticker foods are, generally speaking, desirable, or that people see it as perfectly fine to eat. There's no hassle in that. So because they're significant, then we run all of them in our regression. If, however, one of these was not significant, we would absolutely not include it in the regression. So keep that in mind, kind of underline that twice. If it is not significantly correlated, do not include it in the regression. So let's go down to analyze our regression, drop down to regression, and to the linear regression. Don't worry about all these other types. It's a basic linear regression that we're interested in. So when you click that, the first thing we have to do is select our dependent variable. So of course that's suitability, and we put that in there. We also select all of our values variables because they were significantly correlated, and we put those over there. Now we do need to go into the statistics page. What we want is this R-squared change, and we want the descriptives. So make sure that those two boxes are checked. They're important. Click continue, and that's really all we need to change when we run the regression. So we hit OK, and now we get a bunch of stuff. We'll come back to the descriptive statistics. We can just get rid of the correlations because we've already seen the correlations. You can also get rid of the variables entered or removed because we know that. So here's where we start. Because we had multiple variables, the very first place that we look is to the ANOVA. So we want to make sure first that that is significant because we have multiple variables. We wouldn't care about the ANOVA if we only had one independent variable. So now that we see that that is significant, now we want to see which of our variables actually made a difference. So then we look at the coefficients. So we start at the significance column. The constant, you can ignore that for now. But we look at the social responsibility, and that is well below 0.05. Environmentally friendly behaviors is well below 0.05. But look at this. The domination values are to 0.83. So even though the domination values were significantly correlated, they are not causally related. So if you value control over your environment and strongly care about that, that's actually not predicting whether or not you're going to see yellow sticker food as suitable. That's an important element. This is why we run the regression, is so that we can take out and separate what happens to go together. There's a correlation with what is actually causing the change. So then we look at our anti-environmental values, and that is significantly accounting for changes in food suitability. So we have 3 of our 4 independent variables that are accounting, but how much of the variance are they accounting for? That's when we go up to the last bit, the model summary. and we look for our adjusted R squared. Now, the R square and the adjusted R square. Why do we look at the adjusted R square versus the R square? The adjusted one is just a more conservative or more finely tuned evaluation, so it's always going to be a little bit lower than the R square. So we can see that all by itself, the behaviors and the values that we adhere to, these values affect 23% of our attitude as to whether or not yellow sticker food is suitable for eating, for consuming. That's pretty important. So if we can tap into messages that are about social responsibility and being environmentally friendly, we're going to get some people. But what happens here? This is the tricky one. The anti-environmental values, obviously a message that is all about social responsibility and being environmentally friendly by reducing food waste, that's not an argument that's going to work if you are actually quite strongly anti-environmental. So from a strategic standpoint, the recommendation coming out of this would be that actually you want to have two strains of a message going out. You want the message that you can reduce food waste. You can minimize the problems of it going in bins, of all of this kind of stuff, polluting, creating any damage to the environment by buying yellow sticker food. And guess what? It's perfectly suitable. But you probably also want to make a second argument that looks at anything other than pro-environmental or social responsibility. It might be a cost issue. That making sure that folks say, hey, you can save money by buying yellow sticker food. This is food that's still good. It just may have the packaging might be a little bit damaged, or you might need to use it in just a couple of days. So these are important elements in terms of the strategic recommendations. So trying to sort out how to interpret that data is just as important. So let's go back to our second hypothesis, which was that consumers' beliefs and values will predict the amount of money spent on price-reduced food that has a short expiration date. So we're going to go back to our correlations, and instead of the yellow sticker food suitability, we're going to kick that out, and we're going to put in the short expiration of the last £100 that you spent on groceries. How much of that was spent on food that had a short expiration date? You bump that over. Now, for ease of looking at it, my suggestion is by holding it, you can click on it and drag and drop it up to the top. This just makes it easier to look at on the printout. So that's click, hold and drag and drop wherever you want it. Then you hit OK. So let's take a look at our correlations here. Oh, here we have a little bit of a different story. So social responsibility isn't predicting how much money is actually spent on short-dated food, but environmentally shopping behaviors, domination, and anti-environmental attitudes were all significantly correlated and positively correlated to predict of the last £100 that you spent on groceries, how much of it was spent on food that had short expiration dates. Now let's see if there's a causal relationship. So we go back to regression, linear, take this out, and put in our short-dated food. Let's make sure, I'm pretty sure that is, yep, short-dated food. We chunk in the short expiration date. Because we have just run the other regression, we don't need to change anything else. It remembers it. And let's hit OK. Let's first get rid of the correlations and the variables entered and removed to make it look. Okay, so we start with our ANOVA. It's significant. Good. Now let's look at our coefficients. Well, oh, and I put in, here's what you have to catch yourself. That's why you put it in. is I didn't take out social responsibility. Take that out because it's naughty. Rerun it. Delete, delete. All right. And actually what you notice is that the F went up. So this is why when you take a look at the regressions, why do you want to kick out the insignificant correlated variables? Because it makes your overall test stronger. If you include variables that are not significantly correlated, it actually drags down your test. It makes your test do more work, and you get less predictable, reliable results out of it. So that's one of the important reasons to run the correlations first, and then of course to remember to take them out. So yes, our ANOVA, it is significant. Now let's go down to our coefficients. And look again, domination, significantly correlated, but not causally related. So in this, you have, again, environmentally friendly shopping behaviors and anti-environmental values, both significantly predicting how much food of people's last 100 pounds that they spent on groceries was spent on food that had short expiration dates. So then we come up to our adjusted R squared, and yeah, this is only accounting for about 3% of how much money people spent, but still, environmental attitudes, whether positive or negative, people have reasons for buying the short-dated food. Environmental attitudes are one component of that reason. So again, we're left with a strategic question. Well, how do you use this to understand what kind of strategy? Well, part of it is that you don't only want to make a pro-environmental argument. Because if you do that, you might actually reduce the amount of money that people are spending or the proportion of their shop on price-reduced food. So if the objective is to reduce food waste, or from the company's standpoint, to minimize the profit loss on food that they have to chuck out, you cannot only make environmentally friendly arguments about that, you're going to have some appeal. Now, while our hypothesis confirms that values do predict the amount of money that people spend on food that has a short expiration date, we right now don't have more than the conclusion that you need to have multiple appeals. Because when you have two diametrically opposite sets of values, pro and anti-environmental ones, you need something else in there to explain it. So sure, later on, you could run additional tests on things like gender. You could run tests on their food shopping styles, on a whole litany of things, the reputation of organizations, all that kind of stuff you can run tests on to try and find that out. But what that would, from a strategic point, tell you, you need to have more arguments than just be environmentally friendly, buy yellow sticker food. So, in terms of the overall how to run, we start with the correlations. We make sure that we only use significant correlations. And then when we run our regressions, we start with the check of, is it significant with the ANOVA? We look to our coefficients to see which of our independent variables, if we have multiple independent variables, is causally related. And then we look at our adjusted R square to see what kind of impact that actually has. So if you can keep that process in mind and what each of those things kinds of mean, and then put that together with how you report that, you can start to see how the strategic recommendations come together based on this kind of data analysis. So, as always, if you have questions, I'm about to end the live session as far as what goes up on YouTube and then gets put into the class session right afterwards. But make sure that you ask those questions. Let's go in and end the live stream.